Today we are going to discuss about some more method of preparation of the amines, and these methods include the first one is the reductive amination reaction. When we discuss about the reductive amination reaction, basically this is a reaction of aldehyde or ketones with ammonia. It may be with primary amine and it may be with secondary amine, and by using different type of the ammonia or the amines, we can get different type of the amines. For example, if the aldehyde or ketone react with ammonia, we are getting primary amine, and when primary amine is used and it react with the aldehyde or ketone, the secondary amine will be synthesized, and similarly we can get tertiary amine by reaction of this particular amine with aldehyde or ketone. If we are particularly concerned about this reductive amination reaction, this is a very versatile technique, and by using this particular reaction we can obtain variety of amines, and you can see it in the slide that you are getting primary, secondary and tertiary amine by changing the substrate like ammonia, primary amine and secondary amine. When we talk about the mechanism of this reaction, the mechanism is simply a nucleophilic addition mechanism, in which the first step is the addition of this particular ammonia or the amine with the carbonyl carbon, because this particular carbonyl carbon is electron deficient. So nitrogen along with its lone pair of electron will attack on this particular carbon, and when this will attack at this particular carbon, it will get converted into hemiaminal, and hemiaminal on dehydration means the water molecule will be eliminated from this particular intermediate, and this will get converted into imine. So first of all, when the ammonia or amine is allowed to react with the aldehyde or ketones, it will get converted into imine through hemiaminal. After formation of this imine will undergo the catalytic hydrogenation. It will undergo the reduction reaction, and on reduction it will get converted into the desired product, means it may get converted into primary amine, it may get converted into secondary amine, or it may get converted into tertiary amine, depending upon the type of substrate you have taken for that one. For example, this is a case when we are concerned about this one. This is a secondary amine, and when it is allowed to react with a secondary amine, you are getting here a tertiary amine as a product of reductive amination reaction. When we are talking about the reductive amination reaction, you have seen that you can obtain primary, secondary and tertiary amines, aromatic as well as the aliphatic amines can be synthesized, but you have to work on the concentration of the substrate you are taking. If the concentration has been taken in excess at that time, some side product may also be synthesized, and this is the limitation of this particular reaction, right? And when we are concerned about this limitation, we should be focused on the concentration of aldehyde and ketones or ammonia or the amines we have taken during this course of reaction, right? So we have already seen this, that this is the ammonia, and first of all the amine will be synthesized and then followed by the reduction. This is your primary amine and this is your secondary amine, and by this you are getting different type of amine by using this particular reaction. The second method of formation of amines is the reduction of the nitriles, that is cyanide containing compound, and oximes and the amides, right? So by reduction of this particular series, you can convert the nitriles, oximes and amides into amines. So that can be reduced by using different type of the reducing agent, like catalytic reduction can be used, or reduction by using lithium aluminum hydride can also be used for this particular purpose. And reduction in presence of sodium and ethanol can also be used for particular reduction of a group into amine. For example, this is your nitrile, and when alkyl nitrile is reduced, it will get converted into primary amine. Similarly, this is oxime, and this oxime was synthesized from ketone, and this is ketoxime. So ketoxime will on reduction will get converted into the primary amine, and this is your amide, that is substituted amide, and when this amide reduced, it will get converted into primary, secondary or tertiary amine depending upon the substituent on the nitrogen. So in this slide you can see that this is the cyclohexanone, and this cyclohexanone on reaction with ammonia followed by reduction by using nickel catalyst and hydrogen will get converted into cyclohexanamine, right? So this method is particularly the reductive amination method, and when we talk about this particular method, that is the above one, that this cyclohexanone is first reacting with the hydroxylamine. When this cyclohexanone react with the hydroxylamine, it will get converted into oxime, and oxime on reduction by using sodium in presence of ethanol will get converted into primary amine, that is cyclohexanamine. So from one particular substrate you have two ways by which you can convert this particular substrate into a similar type of the product, but by using different ways. This is the cyanide, and you know that cyanide can also be synthesized by nucleophilic substitution reaction of the alkyl halides, right? So alkyl halide can also be converted into amine by using this particular reaction. So we are particularly talking about this reaction, that this is the cyanide, and this cyanide on reduction, catalytic reduction, will get converted into this is a primary amine, that is 2-phenyl ethane amine is the product. This is your benzoyl chloride, and when this benzoyl chloride is allowed to react with the amine, that is this is ethyl amine, when this react with this ethyl amine, you know, it will get converted into N substituted amide, and this amide on reduction with lithium aluminium hydride, it will get converted into benzyl ethyl amine, which is a secondary amine. So you can see that by using the reduction reaction on this oxime, on this nitrile, and on this particular amide, you can convert these particular substrate, these particular groups into amines, and by using this particular reaction you can get different type of amines by controlling that what are the groups attached with this particular nitrogen, right? So this is the reaction of reduction one. Now when we discuss some more chemical reaction, that is the more methods of preparation of this particular amine, the next one is Hofmann bromamide degradation reaction and the Curtius rearrangement reaction, and this is you know, synthetically very important method, as well as stereochemically. If I am particularly talking about the stereochemistry of this reaction, is really very beautiful. When we are particularly talking about the Hofmann reaction, Hofmann rearrangement reaction, this is basically conversion of amide into amine. Why this particular reaction is called as the Hofmann bromamide degradation reaction is that this is the amide, and you can see that this particular carbon is not present in this particular amine, means one carbon is less in this particular product. So basically this reaction is a kind of degradation reaction. So this reaction is called as the Hofmann bromamide degradation reaction, and this is a very beautiful reaction by which you can convert an amide into amine with one carbon less than the original substrate. This is the case of Curtius rearrangement, and similarly you can see that this is the case of acyl azide, and this acyl azide on heating will get converted into RNH2, that is amine will be synthesized during this reaction, and this reaction is called as the Curtius rearrangement reaction. When we particularly talking about the mechanism of this reaction, you can see that when we are particularly concerned about the mechanism, you can see that this is the amide, and you know that amides are basically amphoteric in its nature, so it can act as the acid as well as it can act as the base. So first of all, as you know, the reaction is being taking place in presence of potassium hydroxide or maybe in presence of sodium hydroxide, means we are having the basic condition. So the OH negative first of all will abstract the proton from this amide, and deprotonation will happen on your first step. When deprotonation is happening in first step, it will get converted into N negative. After formation of this N negative, you know, reaction will takes place with bromine, and this nitrogen negative will attack on this particular bromine, and this will get converted into N-bromoamide. Now the second OH negative will attack on the second proton on this nitrogen, because now the nitrogen is attached with this particular carbonyl carbon and this particular bromine, so it will attack on this particular proton, and again it will get converted into N negative. Now there will be a rearrangement reaction, and how this rearrangement reaction will happen, that this particular R group will rearrange itself along with its electron, that is the electron that is between this R and this particular carbon will rearrange itself to this nitrogen with elimination of this bromine and migration of this electron pair to form N double bond C, and this will get converted into isocyanate. So isocyanate intermediate will be synthesized during Hofmann bromamide degradation reaction. So this is the isocyanate that have been synthesized during the course of reaction. Now this isocyanate will be attacked by the OH negative on this particular carbon bearing C double bond O and C double bond N, with the migration of this particular bond between carbon and nitrogen to the nitrogen, and it will get converted into this particular form which contain negative charge on the nitrogen, right? And after this one, it will undergo the decarboxylation reaction, and on decarboxylation it will get converted into RNH negative, and this RNH negative will finally accept a proton from the water molecule and will finally get converted into amine, that is RNH2. So this is the overall mechanism of Hofmann bromamide degradation reaction. When we are talking about the evidence of this mechanism, that this particular reaction is taking place via the same mechanism as I have told you, is the isolation of this particular intermediate, that is isocyanate, during the course of this reaction. We can confirm that isocyanate has been synthesized during the course of reaction, and that can be very enough evidence for this reaction, for the mechanism of this particular reaction, that if this reaction is carried out with methanolic solution of the potassium hydroxide, at that time, means now we are not taking water, instead we are taking the methanol. At that time you will not get the amine as the product, instead you will get the urethane as the product during this particular reaction. So obtaining of this particular urethane during the course of reaction is a very strong evidence that will prove that isocyanate has been synthesized during the course of this reaction, and it will prove that the mechanism for Hofmann bromamide degradation reaction is the same as depicted in this slide. So that will tell you about the mechanism of this particular reaction. Now, what are the interesting facts about this particular reaction? Because I was telling you in the starting that this reaction is synthetically very important reaction. First of all, R group means alkyl group as well as the aryl group can migrate along with its electron to the nitrogen and to form the isocyanate. For example, this is the case in which this particular R group is migrating and will form this particular amine, and this is the case in which this particular aryl group is migrating and will get converted into the aniline. The second one, which is a very important point about this rearrangement reaction, is that this is basically an intramolecular rearrangement reaction. And how we can prove that this rearrangement reaction is intramolecular? We can prove it by two ways. Number one is the crossover experiment. You can see in the slide that we have taken two different types of substrates. This is one substrate and this is another substrate. When these two substrates are allowed to react in the same vessel by using bromine and sodium hydroxide, that is aqueous solution of this one, you are getting no crossover product during this course of reaction. It means that this rearrangement reaction is intramolecular in its nature. If this mechanism will be intermolecular, at that time crossover product must be synthesized during this course. But there is no crossover product, it means the reaction is particularly happening via intramolecular mechanism. The second point that we can say in the sport of this particular mechanism that this is intramolecular in its nature is the stereochemistry of this particular reaction. When we try this reaction in presence of chiral center, that this is a carbon which is chiral, at that time we will get complete retention of configuration at the chiral center, and this can only be done if the mechanism of the reaction is intramolecular and not intermolecular, right? If it will be intermolecular, at that time we can say that some racemization may occur or some inversion may occur, but here we are getting complete retention of configuration. At that time we can say that the mechanism is particularly taking place in intramolecular way, right? So this is the center that will migrate to this one. So this is your S and this is your product, that S, right? So this is the beauty of this reaction, that Hofmann bromamide degradation reaction. The next one is the Curtius rearrangement reaction, and the similarity between these two reactions, if I am telling you, is that isocyanate has been synthesized as an intermediate in the previous reaction, and same isocyanate will be synthesized in Curtius rearrangement reaction. So this is the similarity during this reaction. The second similarity in this reaction is that one carbon will be less in the product as comparison to the substrate. What will happen in the Curtius rearrangement? I will tell you that basically in case of Curtius rearrangement we are having acyl azide, and these acyl azides on thermal or photochemical heating will get converted into, through this mechanism, will get converted into the isocyanate, which on further reaction with the water will get converted into RNH2, that is amine will be synthesized. This is the case, for example, now the starting material in this particular reaction is the acid chloride. Acid chloride has been taken for this because acid chloride on reaction with sodium azide will get converted into acyl azide, and acyl azide on heating will get converted into isocyanate, and this isocyanate on reaction with water will get converted into RNH2. Again, the mechanism in this case is intramolecular in its nature and will commence with the formation of the isocyanate, and this isocyanate on reaction with water molecule will get converted into the amine. For example, this is your another acid chloride, and this acid chloride on reaction with sodium azide on heating and with the water molecule reaction will get converted into aniline. This is the case of Curtius rearrangement reaction. So if we review our today's lecture, we have told you about the method of preparation of the amines, and these methods include the Curtius rearrangement reaction, that is the rearrangement of the azide in strongly heating condition into amine, the Hofmann bromamide degradation reaction, the reductive amination reaction, and the reduction of Oximes, the reduction of Nitriles, and the reduction of the amides. You can see it here that you are having acid chloride as the starting material. Here you can choose carboxylic acid as a starting material. So if you are choosing here carboxylic acid as the starting material, at that time you can convert carboxylic acid into acid chloride, and acid chloride can be converted on reaction with sodium azide into acyl azide, and then the same reaction can proceed. Means this is the method by which you can convert the acid chloride into amine, and the same method can also be employed in the previous reaction. For example, this is a case of the amide. You can convert your acid carboxylic acid into acid amide, and the acid amide on further reaction with the bromine, sodium hydroxide or potassium hydroxide in its aqueous solution will get converted into the amine. So we have a very versatile method. Means aldehyde and ketones can be converted into amines by using two different ways. Means one was the reductive amination reaction, and the second one was the reaction with the hydroxylamine, and on reaction with the hydroxylamine that was converted into oxime, and oxime on further reduction will get converted into the desired product. right? If we are particularly talking about the nitriles, we are particularly talking about the cyanides. Alkyl halides can converted into cyanides by using nucleophilic substitution reaction, and then the cyanide can be reduced into the amines. Means we have different synthetic routes that we can convert different type of the functional group, different type of the substrate containing different type of groups into the amine as the product. So this is all about the synthesis of amines by using different methods, and tomorrow we will discuss about the chemical reactions of amines.